This is in continuation with the previous session. I have already started with these topics. Okay. So now in creating the Lr0 parsing, we have few steps. Okay. The first step is you are supposed to consider the input string and the context-free grammar that is given to you. And in the grammar, check if the grammar is ambiguous or not. If the grammar is ambiguous, try to eliminate the ambiguity and then consider the grammar. This is the first step that you will be doing. You will be given with the input string, you will be given with the context-free grammar, and check the grammar if it is having any ambiguity. Then if ambiguous grammar is given, eliminate ambiguity and make it an unambiguous grammar. Okay. The next step is, to the given grammar, add an augmented production. Add an augmented production and then consider the augmented production also as a set of productions in the grammar. With having this set of productions, construct a canonical collection of Lr0 items. Canonical collection of Lr0 items. Then, keeping these collections, draw the data flow diagram. That is your finite automata. You are supposed to construct a finite automata for this set of canonical collection of Lr0 items. Then later on, for constructing the parsing table and using or parsing the string, you need the first and follow set, which you have already seen in the LL1 predictive parser. So if you have to construct a parsing table and parse a string, you need the first set and follow set of all the variables that are used in the grammar. In the same way, you need the first set and the follow set for all the variables of the grammar to construct the parsing table. Fine. So using this parsing table, you will be parsing the given input string. So now we'll see these things step by step. So here you can find it is an example of an expression grammar. Expression grammar will be given to you. This will be the expression grammar. E derives E plus T or T. T derives T star F or F, and F derives E within parenthesis or ID. So this is the given grammar, what we have mentioned in the first step. Next, what is the second step? The second step is you have to check if the given grammar is ambiguous or not. Check if this grammar is ambiguous. How do you check it? You are supposed to construct a parse tree. When you construct a parse tree, if you get only one parse tree for the possible input string, then the grammar is said to be unambiguous. Then the grammar is said to be unambiguous. By looking at the grammar itself, you can know that whether the grammar is ambiguous or not. How? The operator with the highest precedence will be placed far away from the start symbol. Which is the start symbol here? E is the start symbol. Which is the operator that is having the highest precedence or highest priority? It is the parenthesis. So parenthesis is placed far away from the start symbol. The next precedence operator is multiplication. So multiplication is placed in between plus and parenthesis. So it means that it is one step having lower precedence than that of the parenthesis. Then the next operator is plus, which is having the least precedence among the given operators, and hence it is placed closer to the start symbol. Okay. So once you check the grammar, if it is unambiguous, then go to the third step. What is the third step? Add the augmented production to the given grammar. Add the augmented production to the given grammar. What is this augmented production? Augmented production is bring the start symbol onto the right hand side of the production rule. Bring the start symbol onto the right hand side production of the rule. So if you have to do that, you are going to add one more production here. If you see here, you can see in the augmented grammar. So all these things, E derives E plus T, it's only been separated as different production rules. Here you have given as OR. Here you have separated each and every production rule. You have added an augmented grammar. The first production rule is called as the augmented grammar, where you are bringing the start symbol onto the right hand side of the production rule. So this is an additional production rule that you have added. Once you add this entire grammar is called as the augmented grammar. E dash derives E. Okay. So from this augmented grammar, you are going to further derive the canonical item set. I've been telling in the previous session what is meant by an item. When there is a dot on the right hand side of the production rule, then it is called as an item. Okay. When there is a dot on the right hand side of the production rule, it is called as an item. When you have such kind of productions, more than one such kind of items, it is called as item set. It is a set of items. It is a set of items. So here if you see, it is a set of items where the right hand side production rule is having a dot. Okay. And what does it mean? If E dash derives dot E. E dash derives dot E means what? Dot is present on the left hand side. The dot is present as the first symbol on the RHS of the production rule, in the sense the parser has not yet parsed any of the symbols. That is, the parser has not seen any of the symbols on the right hand side. So each and every stage or each and every state of the automata, you keep on moving the dot one position towards the right hand side. When the dot moves to the rightmost side, when dot is on the rightmost side of the RHS of the production rule, it means that the parser has seen all the symbols of the production rule. Okay, so I hope it is clear so far. You'll be given with the grammar, context-free grammar. Check if the grammar is ambiguous or not. If it is ambiguous, eliminate the ambiguity. Then add a production rule for the augmented grammar. Augmented grammar is bringing the start symbol onto the right hand side, so that the parser will come to know that it has parsed all the symbols of the grammar. It has parsed all the symbols of the grammar. What is that augmented production rule that we have added? E dash derives E. And from this augmented grammar, generate the item set, canonical item set. What is item set? When dot is there on the RHS of a production rule, it is called as an item. When you have more than one items like this, it is called as an item set. Okay. So keeping this item set, now we are moving to the next step, which is construction of the DFA. So coming to the first step of the construction of the DFA, so you are given with the grammar, you have added the augmented grammar, and then you have generated the item set. Take the first production rule. Take the first production rule. In this production rule, you have dot as the first symbol on the RHS. Okay. Now check if dot is followed by a terminal symbol or a variable. If dot is followed by a variable, then you have to take the closure of that symbol. What is a symbol that is following a dot? E is following dot. Now, which are all the productions where E is there on the LHS? Take all those productions as its closure. When you take all those productions, okay, so E derives E plus T and E derives T are two different productions where E is on the LHS of the production rule. Fine. Now check. Now comes next production rule. E derives dot E plus T. Dot is followed by what? Dot is followed by a variable. What is that variable? E. Now you have to take the closure of E. Closure of E in the sense, add all the productions where E is there on the LHS. You have already added because the first production itself was dot followed by E. You have taken the closure of E. So you are done with the closure of E. Now come to the next production rule. E derives dot T. In this production rule, dot is followed by a variable or a terminal symbol. It is followed by a variable. Followed by a variable. And what is that variable? That variable is T. That variable is T. Now take the closure of T. Now take the closure of T. What is meant by closure of T? Add all the productions where T is there on the LHS. You have two different productions where T is there on the LHS. One is T derives T star F and T derives F. So you are taking the closure of T and adding all productions where T is on the LHS of the production rule. So when you add these two productions, come to the new production rule that you have added. T derives dot T star F. Here if you check, dot is followed by T. What is T? T is a variable. If it is a variable, you have to take the closure of that variable. But in the previous rule itself, you have taken the closure. But in the previous rule itself, here you have taken the closure of T. You have already done that. There are no more productions where T is there on the LHS. So go to the next production rule. In the next production rule, T derives dot F. What is following dot? F is following dot. F is following dot. Okay, so now you have to take the closure of f because f is a variable. F is a variable. So how many production rules you have where f is there on the LHS? You have two productions. F derives, okay, f derives id, okay, and f derives e within parenthesis. Okay, e within parenthesis is one production rule and f derives id is another production rule where f is there on the LHS. Okay, so do you have any more production rules that has to be included? No, because e's closure you have included, t's closure you have included, and f's closure also you have included. When coming to the f production rules, dot is followed by open parenthesis. Open parenthesis is a terminal symbol. If it is a terminal symbol, you need not take the closure. Fine. Next, f production rule is dot id. id is also a terminal and hence you need not take the closure of id. Fine. This is called as one item set, or this is called as one canonical item set, and I am going to name that canonical item set as I0. Okay, I am going to name that canonical set as I0. Now this is the first state of your DFA. First state of your DFA, right? So now what you will be doing is, for the further states, you will be taking one symbol. On that symbol, what are all the transitions that are taking place? Okay, now we'll consider the first production rule here. In the first production rule, dot can be moved one step towards right, one position towards right. On which symbol? On symbol E. Okay, on symbol E, dot can be moved one step towards right, one step towards right. So what happens to the production? If dot is moved one step towards right to E, on E, E dash derives E dot. E dash derives E dot, and you have one more production. On E, dot moves one position towards right hand side. That is, E derives E dot plus T. Okay, there are two production rules which change on input E. On input E, there are two production rules which change. So which are those production rules? One is E dash derives E dot. Okay, on E, dot is moving one position towards the right hand side. And which is the other production on E? It is E derives E plus T. E plus T. Okay, E derives E dot plus T. This is one more production rule. Okay, now I am calling this entire set or this entire state as I1. This entire state as I1. Do I have any more productions where E is there and on E I can move dot towards rightmost side? No, you don't have any more production rules. Now which is the other symbol on which dot can move towards right one position? It is T. Okay, now on T, which state it goes to? On T, you have two production rules. On T, you have two production rules. What happens? E derives T dot. Dot is moving towards the rightmost side on T. You have one more production rule. So what is that production rule? T derives T dot star F. T dot star F. Now check. But before going to the next transition, you have to check here. So here in the previous state, I1 state, you have E derives E dot plus T. Dot is followed by what? Dot is followed by plus. Is plus a terminal symbol or a variable? Plus is a terminal symbol. So you need not take the closure of the terminal symbol. You cannot take. Okay. And previous production rule, E dash derives E dot. Dot is there on the rightmost side. When dot is there on the rightmost side, what does it mean? It means that the parser has seen all the symbols in this production rule. Okay. Similarly, on T, you have two production rules. E derives T dot. T dot in the sense, dot is there on the rightmost side for this production rule. It means that the parser has seen all the symbols on the right hand side of this production. Now coming to the next production rule, T derives T dot star F. Okay. Dot is followed by star. Star is what? Star is a terminal symbol. For terminal symbols, you cannot take closure. Only go to can take place. Okay. So now we are done with the symbol E. You are done with the symbol T. Now what is the next symbol? Next symbol is, in the next production you have F. On F, I name this state as I2 and take a go to the next state on F. I have only one production where F is there on the right hand side, and on F I get one more production which is T derives F dot. T derives F dot. Where is the dot present here? Dot is present on the rightmost side. It means that the parser has seen all the symbols. Here you no need of worrying go to or closure. Okay. What is the next symbol? Next production is F derives dot open parenthesis. On open parenthesis, can you move the dot one position towards the right hand side? Yes, you can move. So when you move, what happens? When you take a transition from I0 to the new state on open parenthesis, dot moves one position to the right hand side of parenthesis. Okay, dot moves here. But what is dot followed by? Dot is followed by E. What is E? E is a variable. So if it is a variable, you have to take the closure of that variable. So when you take closure, you will be adding all the productions of E. All the productions of E. You have two productions of E. You can refer here in I0. What are the two productions of E? The same state will repeat here again. So E productions are E derives dot E plus T and E derives dot T. Now if you see the first production that you have added newly, E derives dot E plus T. Again dot is followed by E. You have already taken the E closure. Come to the next production rule. E derives dot T. Dot is followed by T. T is a variable. Now take the closure of T. Take the closure of T. If you take the closure of T, add all the productions where T is there on the LHS. You get two more new productions. So considering the new production added now, T derives dot T star F. Dot is followed by T. Okay. T's closure you have already taken just now. Okay. Don't worry about it. Come to the next production rule. T derives dot F. Dot is followed by F. F is a variable. Now you have to take the closure of F. Add all the productions of F. You have two productions for F. Add those two productions over here. F derives dot E enclosed within parenthesis and F derives dot ID. So you don't have, because dot is followed by open parenthesis, it is a terminal. Dot is followed by ID, it is a terminal. No need of, you cannot take closure of the terminal symbols. Okay. Now we are done with this set and I name this set as I4. This set is named as, or this state is named as I4. Now I am left out with one more production rule here. F derives dot ID. Can I move dot one position towards the right hand side? Yes, I can move. On which symbol I can move? On the symbol ID. On symbol ID, I can move the dot one symbol, one position towards the right hand side. Now what does it become? The new production is F derives ID dot. ID dot is present on the rightmost side. So you need not worry about the closure or you need not worry about the go to. That is the end of this state and I name this state as I5. I name this state as I5. This is the first step of go to and closure. Go to is moving from one item set or canonical item set to another state in the DFA is called as go to. Go to can happen on symbols, all the possible symbols of the grammar, and closure. Taking the closure is including all the production rules, which all the production rules of the variable where the variable is on the left hand side in the grammar is called as the closure operation. So closure will be taking only for the variables and you cannot take for the terminal symbols. And go to is moving from one state of the DFA to another state. This can happen on all the symbols, whether it is a variable or a terminal. Okay, so this is the first iteration here. Yeah, this is the first transition from I0 to all different states, I1 to I5. Now moving from I1, I2, I3, I4 and I5 further. Okay, where you have to consider all the item sets where dot is not present on the rightmost side. If you take I1, you have two productions here. E dash derives E dot. Leave out the first production rule because dot is already present on the rightmost side of the RHS of the production rule. Now consider the second production rule. Is dot present on the rightmost side? Is it present after T? No, right? So you have to keep on moving the dot one position towards the rightmost side till it reaches the end. That is called as parsing. That is called as parsing. Now we'll start with the set I1 and start traversing to or make a go to the next state. Okay. On plus, leave out the first production rule because dot is there on the rightmost side. Consider the second production rule where dot does not reach the rightmost side of the RHS. Okay. Can you move dot one position towards the right hand side, rightmost side? Yes. How? On the symbol plus. On symbol plus, you can move the dot one position towards the rightmost side. When I move to the rightmost side, what will I get? What production I will get? I will get E derives E plus dot T. Dot was here before plus. Now on plus, dot is moving one position towards the rightmost side. Okay. When you move dot one position towards the rightmost side, dot is followed by what? Dot is followed by what? Dot is followed by a variable. If it is a variable, then what you are supposed to do? You are supposed to take the closure. Add all the productions of T. Add all the productions of T. What are the productions? You have two productions for T. One is T derives dot T star F and T derives dot F. Right. Now, when you consider the first new production that you have added, you have T derives dot T. Dot is followed by T. You must take closure of T. You have already taken closure of T. Now, leave that. Come to the next production rule. T derives dot F. Dot is followed by what? It is followed by a variable F. Now, you are supposed to take the closure of F. Add all the production rules where F is there on the LHS. Okay. So, these are all the production rules that you have added for F. Okay. So, F derives dot open parenthesis. Open parenthesis is a terminal symbol, and dot ID. ID is also a terminal symbol, and you cannot further take closure of these symbols. And I'll stop there and name this state as I6, item set 6. Okay. So, that is on plus. From state I1, you are going to state I6 on input symbol plus. Okay. Similarly, take the state I2. Take the state I2. If you take state I2, you have two production rules. E derives T dot. Here dot is present on the rightmost side. You cannot further go to any other state. You don't have any symbols at all. This parser has already seen all the symbols on the RHS in this particular production rule. Come to the next production rule. You have T derives T dot star F. Okay. Can you move dot towards right hand side, right side? Yes. On which symbol you can move? On star. On star, you can take a transition from I2 to a new state. What is that new state? What happens if dot is moved one position towards right? Your new production will be T derives T star dot F. Now check if dot is followed by a terminal or a variable. It is followed by a variable. If it is a variable, then you have to take the closure of that variable. So take the closure of F. If you take closure of F, add all the symbols, all the production rules where F is there on the LHS. So if you consider this rule, dot is followed by open parenthesis, which is the terminal, no closure. Dot is followed by ID, which is the terminal, no need of taking the closure. So that is the end of go to from I2 to a new state with the name I7. You don't have any other production rules. Now coming to I3. I3, you have only one production rule, T derives F dot. Dot is already present on the rightmost side. So there are no more symbols to move the dot towards right side. So the parser has already seen all symbols on the RHS of the production rule. So you need not take a go to from I3 further to any other item or item set. Okay. So this is the end. This is the final state. Now coming to the next item set, I4. So I4, can I take a transition to another new state? Yes. On which symbol? On symbol E. First production. Consider the first production. If I have to move the dot towards right one position, then which symbol I have to consider? I have to consider E. On E, I will get a new production. What is that production? I have two production rules where on E I can move the dot right hand side one position. F derives open parenthesis E dot close parenthesis and E derives E dot plus C. Check the first production rule. F derives E within parenthesis. Dot is followed by a close parenthesis. Close parenthesis is a terminal. So you cannot take closure of a terminal. Now come to the next production rule. Dot is followed by plus. Plus is a terminal symbol. You cannot take closure of a terminal symbol. So stop. On E, your parser is moving from state I4 to a new state I8. Okay, on input symbol E. Now next, I'll just leave the other stage because I'll tell you at the end, because it is again the repetition of the previous stage. Now I'll start with I6 and then continue to I7 and I8. Okay, so as of now I'll stop here. At the end I'll come back to the state I4. Now I6, on I6, on input symbol T, I can move the dot one position towards the right. Okay, so on T, how many productions will change? There are two productions on T. One production is E derives E plus T dot. This dot is moving towards right side on input symbol T. Okay, so do you need to take a closure here? No, because dot is not followed by any other symbol and it is the final state. It is the end. The parser has seen all the symbols. It has seen E, it has seen plus, as well as it has seen T. All symbols on the RHS are seen by the parser. Now, what's the next production that is changing on input symbol T? It is T derives T dot star F. Dot is followed by what? It is followed by star, which is a terminal symbol. For terminal symbols, no need of taking closure. Fine. So now I name this state as I9. I name this state as I9. Now next, considering next input symbols. This is the next production rule that changes. On which symbol? It changes on F. On F, you have only one production rule that will change. That is T derives dot F. Okay, T derives dot F is when it traverses on F, dot moves towards the rightmost side. What production rule you will get? T derives F dot. Check if you have a repetition of that. Yes, T derives F dot is already done here. It is already done here. And what is the name of that state? What is the number of that state? It is I3. It is again a repetition. So what I can do is I can put an arrow mark to I3. Because the diagram becomes clumsy, I am not putting an arrow mark to I3. Instead, I am just denoting that within a circle. Within a circle, I am putting that it is the same state as that of I3. Okay. Now, if I move, that is about the input symbol F. Now coming to the next production rule. Now I should move this dot one position towards the right side. On which symbol? On open parenthesis. On open parenthesis, what will you get? F derives open parenthesis dot E close parenthesis. Dot will be followed by what? Dot will be followed by E. So if you check that production, it will be same as that of your state I4. Your state I4. You can write and check in your notebook. If you traverse the dot to the rightmost side on symbol open parenthesis, it is just the repetition of the state I4. Okay. So again, I can put an arrow mark to the state I4 on open parenthesis, or to make the diagram simple, what I do is I call it as state I4 within the circle. Hope it is clear. So you are done with this production rule. F derives dot open parenthesis E and close parenthesis. Coming to the next production rule. How can you move dot towards right? It's only on symbol ID. Okay, on input symbol ID. So how does a new production look like? F derives ID dot. Do you already have that state here? F derives ID dot? Yes, you already have it here. On ID, dot moves one position towards the right hand side. So it is just the repetition of the state I5. So instead of putting an arrow mark from there to here, again I am using the same notation to show the state. Okay, so it is the same as that of state or item set I5. So instead of putting an arrow mark to I5, what am I doing? I am just naming that state as I5 here itself. Okay, so that is the transition from I6. From I6, you are going to state I9, you are going to state I3 on F, you are going to state I4 on open parenthesis, you are going to state I5 on ID. Okay, now moving to the next state I7. In the I7, you have three different production rules. You have three different production rules. The first production is T derives T star dot F. Can the parser move or can you traverse the dot one position towards the right side? Yes. On which symbol it can traverse? On F. On F, dot can be moved one position towards the right hand side. That is T derives T star F dot. Now check what is followed by dot. Dot is not followed by anything. It means that this is one of the final states. This is one of the reduction states or the final states, and dot is not followed by anything. So you need not worry about this. Name this state as I10. Name this state as I10. Okay. Next. Consider the next production. What's the next production rule? F derives dot, open parenthesis, E and close parenthesis. Now dot should move one position towards right. On which symbol it should move? On open parenthesis only, the dot can move towards right one position. Now if you move that, you get back one more state. Get back the same state. Which state it is? Dot will move here. If dot moves here, dot is followed by E. So E is the variable. You have to take the closure. Again, it is the repetition of the state I4. Again, it is the repetition of the state I4 on open parenthesis. Okay. So again, it is a repetition of I4. So I am not putting an arrow mark to I4. Instead, I am just putting a circle and representing that on open parenthesis. It is again state I4. Now coming to the next production rule, F derives dot ID. So dot can move one position towards right. On which input symbol? On symbol ID. If I if I go to another state, okay, which state I will be getting? I will be again getting I5, because if I move dot one position towards the right side, I get the production F derives ID dot. F derives ID dot, which is again the repetition of I5. Okay, so that's what I am mentioning here. On ID, I get back the state I5. Fine. That is about the state I7. Go to from I7 on F to I10, on open parenthesis to I4, and on ID to state I5. Okay. Next, coming to the state I8. In I8, again I have two different productions. One is F derives, open parenthesis, E dot and close parenthesis. Now I can move dot one position towards right. On which symbol? On close parenthesis. On close parenthesis, I can move the dot towards the rightmost side. F derives, open parenthesis, E, close parenthesis, dot. Okay, that's it. Dot is not followed by anything. It is a final state or a reduction state. So don't worry about it, and name this state as I11, because this is not a repetition. It is a new state. This is not repeated anywhere in the automata so far. This is a new state, and hence name that state as I11. Now consider the next production rule. E derives E dot plus T. Okay, I can take a transition of this dot towards the right hand side. On which symbol I can take? On plus. If I take it on plus, okay, dot will be followed by T. Dot will be followed by T. If dot is followed by T, now I should take T's closure. Yes. If I take T's closure, just check. If I move dot right one position on plus, will I get back the state I6? I'll get back the state I6. It is not a new state. This state is already present. E derives E plus dot T. If you move dot one position right hand side, E plus dot T. Okay. So dot will be followed by T. Take T's closure. Dot will be followed by F. Take F's closure. So this state repeats again. So instead of putting an arrow mark here, I'll just mention the state number in the circle. Okay. So this is the go-to from I8 to various states. I8 on close parenthesis goes to I11, and I8 on plus goes to I6. Okay. So done with I8. Now moving to I9. Moving to I9. In I9, I have two production rules. One is already the parser has seen all the symbols and dot is there on the rightmost side. The other production rule is still there. Okay. I have to move dot one position towards the right hand side. If I have to move dot one position towards the right hand side, on which symbol I have to take the go to? I have to take the go to on star. On star, if I move dot on star towards right one position, which state I will be repeating? Do you think I will be repeating I7 again? Yes. If I move dot one position towards right on star, I will be repeating the I7 state. So the new production that I will get is C derived C star dot F. Okay. So dot is followed by F. F is a variable. And what are all the productions of F? Include take the closure of those. So instead of putting an arrow mark here, I'll just write on star goes to I7. Okay. So I cannot further take any other go-tos from this state because I'm done with the two productions. Coming to I10. I10 is again a final state or a reduction state where dot is present on the rightmost side. And I11 also dot is present on the rightmost side. I cannot further take a go-to or a closure. Now coming back to I4. Coming back to I4, we have only taken the transition on input symbol E. Now if I take a transition on input symbol T, which state I will be moving to? On input symbol T, am I not repeating or am I not getting the same productions as that of I2? Yes. On input symbol T, I will be moving or I will be getting the same state as that of I2. Okay. And on input symbol F, again I will be getting the production same as that in I3. And on input symbol open parenthesis, it is a self loop. It is a self loop. I will be getting I4 itself. I will be getting I4 itself. And on ID, I will be getting I5. On ID, I will be getting I5. So this is how you construct a automata for an Lr0 item set. When you will stop traversing, when you will stop the go to and closure, two different scenarios. When you will stop performing a go to and a closure, that is when dot is there on the rightmost side of the production rule, you will stop. Okay. The second scenario is when the same states are repeating. When the same states are repeating, you just put a link or just put a flow to that particular link and stop taking the closure and go to, and stop constructing the automata for the given grammar. So this is the second example to construct the canonical Lr0 item set. Okay. So the example is S derives AA and A derives AA or B. So this is the given grammar. So assuming that this grammar is unambiguous, we move on to the next step. The next step is generating the augmented grammar. So what is augmented grammar? Bringing the start symbol onto the RHS of the production. Okay. So I'm adding a new production rule, which is S dash derives S, where S is the start symbol, and now it is present on the RHS of the production rule. So once I'm done with the split up of the production rules and generating the augmented grammar, now I start constructing the items or item set where dot is present on the RHS. So dot is present at the first position of the RHS of the production rule. So hope I am clear so far. Now moving on to the construction of the automata. So what is the first state? The first state is S dash derives, or the first production rule is S dash derives dot S. So here dot is followed by S. S is a variable. Now you are supposed to take the closure of S. So when you take closure of S, include all productions of S. You have only one production rule where S is there on the LHS, that is S derives dot AA. Now in this new production rule that you have added, check what is following the dot. Dot is followed by A. A is a variable. Okay. Now take the closure of A. When you take the closure of A, you get two new productions. A derives dot AA and A derives dot B. If you check the third production rule that you have just now added, A derives dot A. Dot is followed by a terminal symbol. So no need of taking the closure. You cannot take the closure. Fine. Leave out that production rule. Come to the next production rule. A derives dot B. B is the terminal symbol and hence you cannot take the closure of B. So you cannot take the closure further and name this state as I0. I'm naming this state as I0. Okay. Now from I0, I will just take a go to, then take a closure, then take a go to and closure. Go to is moving from this state to another state on various input symbols. Okay. So the next state is on S. On S, I can only move in one production rule. That is S dash derives S dot. So here dot is moved to the rightmost side. It means that this is the reduction state or the final state. Okay. Next, considering the next production. In the next production rule, I can find that I can move dot to the rightmost side on variable A. And I'm naming this as I1 and later moving to the next state on A. What is the new production rule? I'm getting S derives A dot A. Dot is followed by what? It is followed by a variable A. So now you are supposed to take the closure of A. What is the closure of A? You have only two production rules where A is on the LHS. Add those two rules also. Fine. Again, coming to the new production rule that you have added, dot is followed by terminal A. You cannot take closure. Again, dot is followed by terminal B. No need of taking closure. Now go back to state I0 and see you're left out with two more production rules where you can move dot towards the right hand side. That is on symbol A, terminal symbol A, you are getting the new production rule A derives A dot A. Now dot is followed by variable A. If dot is followed by variable A, you are supposed to take the closure of A. Okay. So what is closure of A? You have two production rules where A is there on the LHS. Add those two production rules also. So as we have done in the previous state I2, you are adding these two states and you cannot take closure of A and B because they are terminal symbols and hence I am naming this state as I3. Okay. Next, I am left out with only one production rule where I can move the dot towards right hand side, which is that it is on symbol B. On symbol B, I am moving dot to the rightmost side and further you cannot move because nothing is following dot and this becomes the reduction state or the final state and I name this state as I4. Okay. Repeat the same thing for all the states that you have created now. So I1 dot is present on the rightmost side of the RHS. So you cannot further take a go to or you cannot take a closure. Come to state I2. In I2, you can move dot to the rightmost side in the first production rule. On which input symbol? On symbol A. On symbol A, I can move dot to the rightmost side and I get the final state, one of the final state or the reduction state. Okay. Then I can move dot in the second production. I can move dot towards right hand side, rightmost side of A, and this becomes the repetition of the state I3. If you see, A derives A dot A. You will get on A derives A dot A. So dot is followed by the variable A. So you will have to take the closure of A. So this transition of A of the dot on terminal A is same as that of the state I3. Is same as that of the state I3 and I am making that state as I3. Okay. Next, coming to the next production, A derives dot B. So dot can move one position right hand side on B. Okay. So this is again the repetition of the state I4. This is again the repetition of state I4 on lowercase b. Fine. Next, coming to the state I3. In I3, I can move dot towards one position right hand side on the variable A. On variable A, I can move dot towards the rightmost side. Again here, I cannot take the closure because dot is there on the rightmost side. Dot is there on the rightmost side and that is the final, that is one of the final state or the reduction step, and I named this state as I6. Okay. Now again, the next production is on terminal A. On terminal A, I will be getting the same state I3. I will be getting the same state I3. So I will make a, okay, on B I have taken, on B it's same as that of I4, and on A it is same as that of I3. Okay. Now coming to the state I5, you cannot take a go to or you cannot take a closure because dot is there on the rightmost side. Again coming to I6, a new state. Here also it is the same, dot is there on the rightmost side. You cannot take a closure or you cannot take a go to further. So this becomes the final automata for the given grammar. For the given grammar, this is the automata that we have constructed.